Welcome for today's topic, that is 8051 serial communication. So today's class we are going to discuss about the basics of serial data communication. Then next, RS-232 standards. In this to connect this RS-232 we have a 9-pin connector and 24-pin connector. So we will, in our syllabus we have only 9-pin connector. So we are going to discuss about the 9-pin RS-232 signals, and in the last we are going to discuss about the programming steps to receive and transfer the data serially. So first let us discuss about communication. So what is communication? We, the human beings, speak to each other if the distance is short. And if the distance increases, then what we do is we use different methods like a telephone, a mobile, or an email to transfer the data. So, what is communication? Communication means exchange of intelligence. Okay. So, a other person should know what we are speaking and what we are trying to inform them. So, communication means exchange of meaningful information between transmitter and receiver. So, mainly the classifications of communication is divided into serial communication and parallel communication. So, let us discuss about this classification in detail. So, now let us discuss about this classifications of serial and parallel communication. So coming to the serial communication, here in serial communication, the data has to be sent from sender and receiver. Here the data which will be available will be in parallel format, and it is converted into serial by using parallel in serial out shift register, and then it is converted from parallel into serial out in receiver. So this is about serial communication. So in serial communication, the data is transmitted from parallel in serial out, and then here serial in parallel out at the receiver. So now coming to the parallel transmission. In parallel transmission, here the number of lines required to transmit the data will be equal to size of the data. So here what happens is the data which is transmitted will be very fast in case of parallel transmission, because we are transmitting all the data byte at a time compared to serial transmission. So here, but the disadvantage is here we need more number of lines between the sender and receiver. The number of lines is equal to the size of the data. So what we have seen in that previous figure, so here we have the difference between the serial and parallel communication. In serial communication, we have a transmitter and a receiver, and we have only one single data line which is connected. Whereas in parallel communication between transmitter and receiver, we have many lines, that is equal to size of the data bits which is being transmitted. So the first difference is here in serial communication, only one data bit of data can be transmitted. Whereas in parallel, a group of bits can be transferred at a time. In serial, we use only a single data line, but here in parallel, we use more number of lines, which depends on the size of the data, which can be where complete byte can be transferred at a time. Here, because it is single data transmission, the data transfer rate is low, and in parallel, the data transfer rate is high. Serial transmission is preferred for long distance because if you use more number of wires, it becomes very complicated. whereas parallel communication is preferred only for short distance. Coming to the cost, the serial communication is cheaper because you have only one single data line, and here it becomes expensive. The next difference is the serial communication, it is slower when compared to parallel, whereas parallel is faster. The data byte in serial communication should be converted into parallel in serial out shift register and then transmitted over a single line. But here in parallel communication, there is no need of conversion. In serial, for very long distance, we use a modem. Modem is nothing but modulator and demodulator. To improvise the speed, we use this modem. Improvise the speed and long retention of data. In parallel communication, no modem is required. So how the serial communication works? So as I told in the previous figure, the serial bits has to be converted into the parallel bits should be converted into serial out shift register, and then the transmission takes place. At receiving end, there must be a serial in parallel out shift register where the received serial data is then converted into parallel for processing. Now, the next topic is what are the methods of serial data transfer. Here we have three methods, which is simplex, half duplex, and full duplex. So now let us see about each method in detail. So coming to the methods over here. The first one is, here we have three different transmission modes: simplex, half duplex, and full duplex. So what is simplex? In simplex means the data is transmitted in one direction and the device can only send the data but cannot receive. So a very good example for simplex is radio. Next, coming to half duplex. In half duplex, the data can be transmitted or received but cannot do both simultaneously. So a very good example is a walkie-talkie. Next is full duplex. In full duplex, the data can be transmitted and received simultaneously at the same time, which is called full duplex. A very good example is a telephone or a mobile phone. So here, once again, we are going to discuss about the same points. Simplex, the data is transmitted in only one direction. Okay. So the other direction, it cannot be transmitted. So transmitter will transmit and receiver keeps receiving. In half duplex, the data cannot be transferred in both the directions. It can be transmitted in both the directions, but not simultaneously. Here we have a dedicated transmitter and receiver. So we will have, if the transmitter transmits, the receiver on the other side can receive, and if this transmitter is active, this receiver will be active. So at a time, either a transmitter or a receiver can be active. In full duplex, the data can be transmitted in both the directions simultaneously. So a very good example is a telephone and a mobile conversation. Next, how the serial communication can take place. It can take place in synchronous and asynchronous methodology. In synchronous method, what we do is we just continuously keep transferring a block of data, and this data is referred to as clocks. Example is SPI bus and I square C bus. In asynchronous communication, the transfers can be a single byte at a time. Here we do not transmit any clock signals, but every byte is accompanied with a start and stop bit. So example is an UART, universal asynchronous receive and transmit. So now let us see an example of synchronous and asynchronous data transmission. So we have a transmitter and a receiver, and we have a connecting wire for serial communication, single wire. So in case of synchronous data transmission, the data which is given from transmitter will keep on going to the receiver. So it is in synchronous with the time. The data keeps on moving from transmitter to receiver. So it is also called clock signals. Okay. So the transmitter keeps transmitting and the receiver keeps receiving. Here the yellow line indicates the bits transmitted. Now coming to asynchronous mode of transmission. Here let us consider the data of size 8 bits. So this data of size 8 bits has to be transmitted from transmitter and receiver. So this data bytes can constitute an ASCII character. So to transmit this data byte, I need a start bit and followed by the data bits, and in the end I have a stop bit. So a start bit and stop bit will be indicating when the data arrives and when the data stops. So here the logic high is indicated as mark and a logic low is indicated as space. So here we have the baud rate will be set over here in this asynchronous mode of transmission. So here what happens is first the data bit followed by first is start bit followed by 8 data bits, and then stop bit will continuously keep transmitting to the receiver. So whenever the data arrives, initially it is in mark position, that is logic high. So the data, once it becomes low, it indicates the start bit has arrived and the next corresponding data bits will be arriving. After receiving all the 8 data bits, then it will receive 2 stop bits. So here we have an example of the see, initially we have taken a small data of size 8 bits, that is an ASCII character 100 10010. So initially the data, if it is receiving only logic high or only mark, then the receiver is known that it will understand it will not receive any data. So the first one, suddenly once it goes low for one clock cycle, it shows that the receiver gets alerted that it will receive the data, a small space over here. Okay, this is called a start bit. So once the space is received, the receiver understands it's going to receive 1 byte of data. Now this 8 bits of data comes into picture. So first start bit will be transmitted from transmitter to receiver, then D0, D1, D2 bit, D3 bit, D4, D5, D6, D7, and then the space. So this space usually it will be of size 1 or 2 bits depending on the transmission modes, asynchronous transmission modes of transmission. Okay, so this is about asynchronous transmission. So today for this lecture, let us stop our lecture over here.